This one we can actually keep pretty quick, because while DynamoDB is one of the most important, most powerful, and most popular tools in the AWS arsenal, the configuration is a lot simpler than anything we've been looking at so far in AWS EC2. DynamoDB is huge. Amazon internally mandates that all new products use DynamoDB because of its scale, its speed, and its reliability. It has ridiculous scale, terrifying scale almost, trillions of records in some tables. DynamoDB is both more and less than a replacement to other NoSQL options like Mongo or Cassandra. It has unique capabilities and unique restrictions, but those restrictions are what allow it to really achieve that massive, fast scale. I've been wrapping my head around how to use it well recently thanks to Alex DeBrie's really good book, The DynamoDB Book. Stop Fighting Your Database, The DynamoDB Book. You should check it out here at dynamodbbook.com. I'm relatively new to Dynamo myself, and this book has taught me how to model my data and my indexes to take advantage of Dynamo without shooting myself in the foot. I can achieve that kind of scale that Amazon is achieving with this tool. I really recommend, if you're going to use Dynamo in production, get this book and learn how to properly model your data so that you can achieve the scale and performance. Alex has one of the most popular reInvent talks as well on Dynamo data modeling, so check that out. I'll put the link in the show notes. We're going to do 4 things in quick succession in this video. We're going to import an existing DynamoDB table that I've already created in my AWS console. Then we're going to launch a new one from scratch using a very simple approach. It's only going to be about 3 or 4 lines of code to create a whole new DynamoDB table. Then we're going to try launching again, but we're going to get a bit more complicated with the parameters we pass. This is where we're actually going to steal an example from the book that we talked about, where we're going to use single table design, which is the recommended awesome new way to do things, and we're going to create some global secondary indexes as well on the Dynamo table. And then finally, I found a neat new trick where we can actually insert data, some seed data, some config data, some test data, into our DynamoDB table from within our CDK when we launch it. So let's get started. As always, we start with the CDK docs. Here's the DynamoDB module, which walks through simple examples to import or create tables. We can see there's one main construct over here, the table construct, and actually DynamoDB is very simple to configure from a CDK perspective. There's an example right here of importing an existing table into your CDK, and it says that we can use the table name, the table ARN, or the table attributes to find the table that we want to pull in. I have an existing DynamoDB table in my account that I want to use in the CDK project, so let's check that out. Here we go, users table. The easiest way to reference a specific existing resource is by the unique ARN. So if we scroll all the way down to the bottom, we can find that right here. The ARN, and you can always see the way they're constructed. AWS DynamoDB is the product name, US West 1 is the region that we're in. This is my account number, and then table/users. This part is unique to the service or the product that we're using. So you can actually construct these for any resource that you know of in AWS, and as long as you have permissions, you can access it or refer to it. So let's create a CDK project quickly for this. This is an empty folder, so we're going to do a CDK init. Good, welcome to your CDK project, excellent. Now let's install the Dynamo package. Good, now first thing we need to do is here in our top level script, let's create some config for ourselves. We're going to need to give it a name, go Dynamo. We're going to need to specify our basic environment that's common to all stacks, and that includes our, cut and paste. Our account and our region. And then let's put in that user table, our ARN, that we get from the console. Right down there, copy, paste. Good. Now this can be passed in to the stack that was made for us. But of course that's not the stock stack that is expected. Of course here it's expecting a CDK stack props. So let's create our own stack prop class quickly. And we're going to extend the stock one so we don't have to retype everything, honestly. So now that's going to automatically include the environment and anything else that needs passed in. But we're going to give it our org is a string that I like to use, and of course our user table ARN. That's it. And of course we make this get passed in, and it's required. Good, so far so good. So we're passing in this config with the ARN and our account information to the Google Dynamo stack. You know this stuff by now. Now let's actually start creating a table. We need to import our library. Import everything as DynamoDB from AWS CDK, AWS DynamoDB. Thank God for autocomplete, otherwise I would screw that up. Now let's import our table. On our Dynamo module, we have our table construct, and look at that, from table ARN. Scope is this. ID, we'll just call it a user table for now instead of getting fancy. And the table ARN is, of course, props.userTableARN. That should do it. Let's also just output something so that we know this is working okay. I'm seeing the red underline here, which is usually the case because I need to update my CDK. So I'm going to do that really quickly, and now we're going to deploy it. Done, that was easy. We've got our users table being output here with the name users, no surprise there, but we can tell that it's working. Okay, let's create a second table for the teams our user might belong to. Teams will have a name. Let's go back to our CDK docs and check out the constructor properties for the Dynamo table. Here we go, construct table. We're going to say new table, straightforward there. Table props. These are all of our constructor props. We can see most of them are optional. I'm definitely going to want to specify a table name instead of letting it be randomly assigned. I'm not sure what would happen otherwise. And we definitely know a partition key is required. So let's go get started on that. DynamoDB.table, sorry, it's a new DynamoDB.table, this. Okay, let's see what we need to do here. We need to add a table name. I want to specify a billing mode. You can see that here, billing mode takes a billing mode. And this specifies how you're charged. I always like to start out on pay per request, which is the pay-as-you-go billing. I don't want to switch to provisioned early in my project. Later, once we're live and I can see actual traffic, then I'll worry about provisioning. Right now, let's just do pay-as-you-go. So I'm going to specify a billing mode.pay per request, which I'm sure autocomplete will help us with. Sorry. Look at that. Easy peasy. Now every table needs a partition key as well. Let's back up and see how those are formatted. Partition key is an attribute. I bet if we go to the overview example, we'll see how a partition key is supposed to be formatted. There we go. Their tiny example here of all that's required for a new table gives us a perfect example. So let's set a partition key. ID is fine for me. My team is going to have an ID and it is going to be of type string. No problems there. Good. Let's output this table name as we go so that we know things are working, and let's deploy it. And because we know that that is specified, actually, let's live dangerously and see what ARN it gets as well. Deploy. Sweet, look at that. This instead of actually, so the first time we deployed, it was very quick. It only took 1 minute, actually less, because all it needed to do was find the reference to the existing table. This time around it took a bit longer. It took from about 306 to 306:30, only 30 seconds still. DynamoDB tables are very fast to create because it needed to go create it from scratch. So only a matter of seconds to look it up, 30 seconds to create a new one. Still, that's awesome. We can iterate fast. Team table name is teams, team table ARN is this ARN string, and the user table is users. So we've got our two tables in our CDK code. Now I want to go back to Alex's incredible book on DynamoDB and data modeling. It's critical that you learn to use global secondary indexes and local secondary indexes. And in fact, the best practice now is to only use one Dynamo table, not the two like we just created, and to put all the different types of objects in that one table. A single table architecture with multiple indexes and multiple entity types as ways to look up the data in that table. So let's create a bit more of a complicated table this time instead of a minimal one that represents that better single table approach, and we can use an example straight from this book. Down in chapter 19, he does a detailed walkthrough of designing an e-commerce order system using single table design, and this is the final layout here. With multiple entity types in the table, you can see there's customers, there's orders, there's order items. We need to overload the partition key and the sort keys of our DynamoDB table based on what object type it is. And we're going to add global secondary indexes, those are what he was highlighting here in red, for other types of lookups. Now this looks complicated. This is an example of where the different object types and values will live from his work here. This is really the best practice for leveraging the scaling capabilities of DynamoDB. What's surprising actually is that we end up with a very simple table design. If we jump down a little bit further here, we can see the final entity chart. Basically, we're overloading two main fields, the primary key, partition key, and the sort key, and then we're creating a global secondary index. We're only creating one. GSI, global secondary index 1, has a primary key and a sort key. So for our different entities, customers, customer emails, address, orders, order forms, order items, we're creating a primary key, a sort key, a global secondary index, and a sort key for that one as well. You can see that our orders are stored with the same partition key as our customers. Customer hashtag username. This allows us to rapidly pull a customer and all of their orders, or either or, with a single query. We don't need to hit it over and over to grab each order. We have a secondary index that does the same for orders, being able to grab both the order and the order items because they're grouped under the same primary key. This means they're stored together on the same partition, and we can get the whole set of them, order, record, and each item, in one query. This is where we're really starting to leverage the speed of DynamoDB by getting into the nitty-gritty of these access patterns. So it's pretty simple to accomplish great things with minimal code, which reminds me a lot of the CDK and why I love it. So let's update our table definition to add some more fields. First, let's say we're not working with teams anymore. We're going to use this as our omnibus table. We're still going to load our user table because maybe that applies to all of our staff users and workplace. Great. So now we have a single table named bookstore. It's still paper request. Now, partition key, instead of the ID, we're going to define, remember they were PK and SK. Partition key is going to be PK. It's still going to be a type of string. And then we need to assign a sort key as well, named SK. And it's also going to be of type string. That lets us really overload it. Then we need to define our global secondary index. We add that with a second function call. There we go, add global secondary index. And this is actually pretty straightforward. It has the exact same structure. It takes a partition key and a sort key, and we need to give it an index name. Partition key, sort key, but we're going to name those GSI1 PK and GSI1 SK. Almost did that wrong. And then let's update our outputs here. This is no longer our team table. This is our single table. Good. If your layout has local secondary indexes or other types of index, there's only 1, 2, or 3 in DynamoDB, you add them very similarly with another function call. There's an add local secondary index function as well. That's it. Thanks to this simple layout of single table design, we're able to keep our table definition and our CDK really simple and straightforward while creating really sophisticated data access patterns. There we go, deployed. It created the new bookstore table. Now let's go take a look at the console itself. You'll see because I changed the name of the table entity itself within my CDK, it didn't know to delete the old one and create the new one. When it parses the CDK code, when it uses the CDK code to create the CloudFormation code, it doesn't notice that something disappeared and something else appeared. Instead, it just sees that there's a new entity there named bookstore. So I'm just going to delete my old teams table here manually. And if we go look at the bookstore table while that's happening, we can check that sure enough, it has its GSI index with a GSI1 PK and a GSI1 SK. And its primary partition key is a PK and its primary sort key is an SK. So this is exactly what we intended to be created, and it is empty. There we go, no items within it. I have something cool I want to show you actually, now that we have our table, that deserves a whole lesson on its own, but I'll demo it here and I'll link to a more detailed article. You can use custom resources from the CDK, that's this other tab I had open here, to actually insert some initial records into your DynamoDB table at launch time. This is going to be really useful for either required config data, like say shipping rates for your bookstore that you always need, or for testing data, like fake customers and orders. I'd like to break this out into separate functions and constructs like we did with our SSL on the load balancer or with database size options in previous lessons. But to keep this short and quick, I'm going to load a single fake customer into this new table. So custom resources let us call AWS APIs during our deployment, which is perfect. Like this, imagine the different things you can do by just calling random AWS APIs during your deployment. So we're going to call the DynamoDB put item API to insert a record and have it done when the table goes live. We need this extra module here, so we'll install that quickly. While it installs, we'll include it at the top. Let's create a quick fake customer once the table is created. Now we're going to need to specify here exactly what's going to be inserted by the API call. So we're dropping into like really basic DynamoDB API layout. So primary key is going to take a S for string. And I remember from our example in Alex's book that we're going to do customer hashtag jmagnus, if I can type my own handle. And our SK is also going to be the username. And then we're going to add some attributes that our customer might have. So let's say first name, I'm Jeff, and last name. Son of Magnus of the Icelandic Magnusons. There we go. So I have this anonymous object called fake customer. That's what needs inserted. And then let's do this with the custom resources. New custom res is what I called it, .aws custom resource. As with every construct, we're going to say this. We're going to give it a name. And get into our props. So I'm copying this out from an example. I'm going to post some notes, actually a really detailed blog post in the show notes. So on create, when this CDK stack gets created, there's other options if you want to do on update, etc., that you would reinsert or rerun this custom resource on every update. I'm going to do this insert once when this stack gets created. So on create, we're going to call a service. And here you're using the same capitalization, etc., that the API uses. Because all we're doing, this is going to create a Lambda function to call the API and then destroy it again. We want to call the DynamoDB API. We want to run the action, put item, and pass some parameters. Such as table name, okay, I remember seeing in the documentation that one thing we need to provide for the onCreate is a physical resource ID, which has a bit of a funny structure, and I'm going to rush through this a little bit because it's just required as a unique ID. And then outside the onCreate itself, we need to insert a policy. We need to give it a policy, an IAM policy, that this Lambda is going to assume. It's a session-based policy to allow it the access that it needs. So this lets us specify exactly what permissions and capabilities this Lambda function, this custom resource, is going to have to execute its code. So I'm going to quickly craft one here. custom resource policy from statements. This is a custom piece of this module itself. You can find in the documentation. It takes an array of statements. So we're going to pass in a new IAM.policy statement. And I checked the documentation around this just recently, so hopefully this all works out for me. We're going to allow actions service : API call, and we're going to allow it on resources our table by ARN. There we go. So now we could be sloppy and we could put an asterisk in here or a star or a constant to allow all resources or to allow all put item. I mean, this is a very short-lived piece of code. This Lambda function is only going to exist while this runs at the end of our CloudFormation. So it would not be a giant security risk to just open this wide up, but I don't like doing that. Principle of least privileges, we should give this permissions to do just what it needs for the time it needs to do it. So we're going to do dynamo put item on this table that we just created, and that's the policy we're going to give this snippet of custom code. Okay, let's run it and hope everything goes the way I expect it to. Say yes to the new permissions. Okay, error. This stack uses assets, so the toolkit must be deployed to the environment. Run this bootstrap command. And I know from previous errors that, of course, I need to also pass in my profile. This is because our script right now is actually generating Lambda code, bundling it, and uploading it. So there's some built-in CDK tools around the bundling and the assets, and we just need to put the other side of those, like a staging S3 bucket, into our environment. Good, this little detour is done. Let's go back to our deploy and accept the permissions again. Nice, done. That took a little bit longer, but we see the same finishing state. User table name, single table ARN, and single table name. So everything deployed just the way we expected it to. And we see up here, we can see the new policy being deployed. We can see the Lambda function, and we can see our custom resource fake customer inserter doing its thing. So hopefully that all ran as expected. Let's go back over to the console and take a look. There we go, bookstore table with its PK and SK. And if we go take a look under items, huzzah, look at that. Customer J Magnus, PK string, customer hashtag J Magnus, customer hashtag J Magnus, first name Jeff, last name Magnuson. It likes me. I'm there. I think that's pretty amazing that we were able to use a snippet of code in our CDK itself to deploy data using the API. Like that we were able to actually trigger basically random API calls from our code. We can do this on deploy of a new stack. We can do this on update of any existing stack in the CDK. And here, I mean, this specific use case is fantastic that we could put configuration data, seed data, test data into our DynamoDB database using this. Great. I wanted to say one other thing quickly before we go. I mentioned that there was a database of all of the IAM resource types and actions. That's a great resource. This is it right here. I'll put the URL in the show notes, but you can go find every single possible action and resource and what the filters are you're able to do on it. So this is where we could look up what we need to be able to do a put item on the table and how we can filter that stack to keep our privileges nice and tight. Cheers. Thank you.